Okay, now we're going to talk about capacitors in series and in parallel. And this will prep us for talking about resistors in series and parallel in the future. And so if you have two capacitors and they're linked like this, that's called a series. So you have C1 and C2. So the equivalent, or the total capacitance of this is 1 over that is equal to 1 over C1 plus 1 over C2. And that's how you do the calculation. If, on the other hand, you have two capacitors and they look like this, so they are linked in this manner, then the total capacitance is equal to C1 plus C2. And as you'll see, this is exactly the opposite of series, and this is parallel here, series and parallel resistors. But we'll get to that later. But if you have them, if they're in parallel, you add them, and if they're in series, you do this calculation. So let's take a look at the problems with that in mind. So the first problem says that you have, this is problem number 57, says that you have three capacitors. You have one that goes like this, one that goes like this, then it comes back around like that, and then it comes out here, and there's a third one here, okay? And so this is C1, this is C2, and this is C3. And this one is 10, and this one is 20, or 2.5, excuse me, and this one is 0.3. So the way I do these is I take two of them that are obvious, and sometimes it's three, but let's say it's two. And these two are obviously in parallel. So we could say, well, we could substitute a single capacitor just by adding these two together. So this parallel group is equal to 12.5, the sum of 2.5 and 10. So now your diagram looks like this. So you've replaced it with two capacitors, one which is your equivalent to the parallel group, and then C3. And so C3, so the answer here, so the total equivalent is going, the 1 over that, these two are now in series, so they're in this formula. So it's 1 over Cp that you just calculated plus 1 over 0.3. So that means that the total, and the easiest way to do this is to multiply, in the top you put the multiplication, so 12.5 times 0.3, and in the denominator you put the sum, 12.5 plus 0.3, and if you do the math here you get 0.293, 0.293 microfarad. So that's number 57. 60 is very similar. It's just the sort of the opposite of this one. So you have one capacitor over here, and over here you have two. Okay, so now this is C3, this is C1, and this is C2. And C2 is 2.5, C1 is 10, and this one's 0.3. So they all have the same values, they've just been rearranged in a different way. So now the obvious one here is this. These are two in series. So 1 over C3 plus 1 over C1 is going to be equal 1 over the two in series. So that's going to equal 1 over 10 plus 1 over 0.3. And if you do the math on this one, you end up with 0.293 0.291 microfarad. And so now you can redraw this now as a, so that it looks like this now. So that it's just two capacitors in parallel, which you just add together. So you take the, this one is now the CS and this is C2. So the total is going to be 2.5 plus 0.291. And so if you do that, you get 2.79 microfarad. Now number 61 gets pretty rowdy. And you have, and I'll tell you, it takes a little more time, and I'm going to go through this pretty carefully. It takes a little more time, but if you do it the way I'd show you to do it, you'll do better. So let me draw the original first. So this is 61, and if you do this now when we're doing circuits and resistors, you'll find that it will help with those as well. So let me draw this out first. You have two there, like that, and then it comes around to one here, and then it comes over this way, and you have one here, and you have something that comes off like this, and for this one you have one here, and then that comes up like that, okay? So you end up with a total of 5 of these. 1, 2, 3, 4, 5, 6 of them. 6 of them. And it's, so you have 1, 2, 3, 4, 5, and 6, okay? And the first thing that I notice is I'll go from one end to the other. And you can do this either way. You could go to this one and eliminate it first. Okay, C5 over C and C6. Or you can come over here and you can take these two that are in parallel and you can eliminate them. And I just happen to do that. So C1 plus C2 is equal to this first parallel one right here. And so C1 plus C2 is 0.75 plus 15. So it's 15 plus 0.75, so it's 15.75. Now when you do that, what I do is I draw the picture again, because this helps me not screw up, okay? Now you don't necessarily have to draw the picture again, but for me, it helps me keep it straight. So all of this is the same, and you have this one, which is the same, but now this has been replaced by a single, and it looks like that. Now so this one is 3, this one is your CP that you just did, this is 4, 5, and 6. Now at this point, you can take this one and change it. You can take this and change it. You can do both of those, and then you'll end up with 3 in parallel, okay? So let's do that. So that means that 1 over C5 plus 1 over C6 is equal to 1 over CS1, or let's call it 5, 6. And that 1 over C3 plus 1 over CP is equal to 1 over CS3P. Okay, so that, when you do those two calculations, you'll end up with 1 over here, 1 in the middle, and 1 on this side. The 1 over the middle is going to be C4. The one over here is CS5, 6, and the one over here is CS3P. So this is going to be, let's see, 5 and 6 were 3.5 and 5. So this is 1 over 3.5 plus 1 over 5 is equal to 1 over CS 5/6. And this one's going to be 1 over C3, which was 1.5, plus 1 over 15.75, you got that from up here, is equal to 1 over CS3P. And then once you get those two numbers, all you'd have to do is take C3P plus CS5/6, which will be your answer here and your answer here, plus C4, which is 8. And it turns out if you do this math, I'm not going to do it all, but if you do this math, you end up with 11.43. And I guess it's microfarads. So if you do this one step at a time and redraw as you go along, it helps you keep track of everything as you go along. Hopefully that'll make it easier. We have 2 problems left. The first one is both are under the section of energy stored in a capacitor. What is the energy stored in a 10 microfarad capacitor of a heart defibrillator charged with 9,000 volts? Okay, so we previously said that the energy stored in a capacitor is equal to the capacitance times the voltage squared over 2. So we put the numbers in. The capacitance was 10 microfarads, so 10 to the minus 6 faradays, times the voltage, which was 9,000 squared, divided by 2. If you do the math here, you get 405 joules. The second part of this says find the amount of stored charge. Well, remember, charge was equal to the capacitance times the voltage, which is 10 times 10 to the minus 6 times 9,000. And so that's going to be 9 times 10 to the minus 2 coulombs, or 90 millicoulombs. Last problem. 66. 66 states, suppose you have a 9-volt battery and a 2 microfarad capacitor and a 7.4 microfarad capacitor. Find the energy and the charge if they're connected in series and parallel. Well, first of all, you have to find the capacitance for series. So the total capacitance is going to equal the individual capacitance like this. And so that's going to be 1/2 plus 1 over 7.2. And that's 1 over CT. So CT is 2 times 7.24 divided by 2 plus 7.4, which is equal to 1.575 microfarad. So that's if they're connected in series. So the charge, if they're connected in series, is going to be 1.575 times the voltage, which is 9 volts. And that's going to be 1.42 times 10 to the minus 5 coulombs. This was micro, remember. So this is micro, so this I should have actually put 10 to the minus 6 here. Now if we, and the energy for that, so the energy for this is CV squared over 2, so it's going to be 1.575 times 10 to the minus 6 times 9 squared over 2. So that's going to be 6.38 times 10 to the minus 5 joules. Now the only difference in there, if they're in parallel, is you just add them. So the total is going to be 2 plus 7, so it's going to be 9.4 microfarads. So you do the same calculation here. So Q is going to be 9.4 times 10 to the minus 6 times 9. And then E is going to be 9.4 times 10 to the minus 6 times 9 squared over 2. This is going to be 8.46 times 10 to the minus 5 coulombs, or 8.84.6 microcoulombs. And this one, 3.81 times 10 to the minus 4 joules.